You have to take proper section in high dimension. I'm not good at drawing that. I wish I had my first coat or a master, Montrucchio here. He was unbelievably good at doing that. And he could do it in 4 dimensions with different colors without making a mess. And I was always like, oh my God. I have never learned, so I will not try. So I have to appeal to your imagination. But obviously you can imagine, so one way we can do it is 2 inputs and 1 output. That I know how to do it. So follow me here. Right, let's do this. So these are the 2 inputs, and that's the output. Okay? So what's an activity here? An activity here is a combination of inputs like that, and then something vertical that is a level of output. And that's the activity. And you can imagine the activity to be a ray that comes out from the origin and goes out there. Right? Now if you fix this, so you fix the hyperplane there, the output level, right? And now you can hold that and travel here, where this corresponds here to a different combination of inputs but the same output. And then you can travel, I don't know, here and do the same. Now on the 2-dimension plane, you have an isoquant that here appears as a straight line, here doesn't, right? It combines. If you do this repeatedly for many points, you'll get a smooth isoquant. That's the smooth isoquant of your production function. So when you look at it carefully, what you're actually describing is technological change. As you travel along the isoquant and you replace one input for another, by holding the amount of output constant, you're actually changing technology. Okay? Or not? I'm happy to do it again, but you have to ask me which part of my graph makes no sense to you. Let's do it in a familiar language. And we actually can invert the graph. So we'll do G and P, and we call that capital, and we call this labor. Okay? And for a given technology, a given combination of inputs and output, if I take these 2 quantities of L1 and K1, I will have a certain, see, one of the reasons I cannot replicate ridges is that I cannot draw straight lines. Okay, it's very important to draw straight lines to give the effect. So that's the level of output, Y1. That's a technology, do you agree? For a given set of machines, a set of workers of a certain type, and machines of a certain type, we get a certain number of sweaters. That is a point here in 3 dimensions, in the middle of the room, and there is a ray from the origin coming up here. Now I'm going to pass, hold this constant, so there's going to be like, you know, an hyperplane going through here at that height, okay? And I'm going to hold that output constant but change the combination of inputs. I'm going to use a a technology here that uses more labor and less capital, and a technology here that uses more capital, less labor. But all of them are associated to the same level of input, sorry, of output. Right? So this is associated to the same level of output here, same as this, and this is also associated here to the same level. But from the point of view, so they're all on that cylinder. Well, one point is there, one is here, and one is here. So there are three different rays from the origin. Same level of height, but different coordinates on the room floor. That's the isocurrent. When you project that on the floor, that's the isocurrent. And if you do that smoothly for millions of points, you can get your smooth isocurrent. Right? And then now you can do your cost minimization analysis by saying, here is a price, wage, rental rate, here is a wage, rental rate, and I move from here to here. I do capital labor substitution. Correct? That's what we talk about every time. But if you think for a moment, and if you think of reality out there, you realize a lot of business cycle mysteries, let alone growth mysteries, have to do with that. When we do this on our aggregate production function, we jump from here to there because a change in relative prices, or a technological shock we call it, change in relative cost and profitability of using more capital and less labor, over time we do it instantaneously. We expect to see it in the data in a quarter, 3 months. In practice, that requires an innovation and a construction of new capital, let alone sometimes construction of new labor. This is a country that in its recent history knows exactly what I mean. Right? How long does it take to make him? The country needs to get a lot more capital, human capital, to put into production to replace physical capital to produce new human capital. But you can increase the salary of a university professor as much as you want. You're not going to have a lot of university professors with good PhDs within 3 months just because you pay them double or 3 times, right? You have to wait a few decades. Right? This is true in everything, right? We all would like to replace old airplanes with new ones, given the incentives. Fuel efficient as opposed to fuel inefficient. But it takes time to build airplanes, it takes time to train the pilots to fly the airplanes, it takes time and resources, and that's technological change. So yes, we observe. That's why this is a very beautiful tool if you use it properly. Because it allows you to think simply at the long run, and if you calibrate appropriately to the unit of time at which the actual technological change takes place, you can see that the price. So if you do it, for example, for energy consumption and the type of machinery in many industries in the Western world, or in cars, for example, or airplanes, any transportation means, since the 70s, you'll see that, right? The substitutability, the technological improvement that reduces energy consumption per unit of output by changing capital goods, making capital goods maybe more expensive, but because more expensive, more efficient, to a point that it's convenient to use the new car, even if it is a little bit more expensive per unit of cars to produce than the old one, right? Because you have to put the R&D, blah, blah, blah. But you reduce energy, you can see it, but you're not going to see it overnight. You're going to see starting in 73, if you interpolate all the points, and in late 80s, then after 15 years, you have seen the smooth isoquant coming out. But it was technological change motivated by a change in relative prices due to, in this case, a fairly exogenous shock. It was mostly a political shock. This is something you learn from von Neumann, right? So that's, you see, the convex cone and neoclassical theory. The convex cone and neoclassical theory is this. That's the way it's created. The guy that understood how to do it right was him. Varra had version of it, other had version, but they were somewhat confused. Von Neumann had it right. And the first to use it properly to prove existence was Lionel Mackenzie. So Lionel too was being a student of von Neumann, understood that this was the neoclassical production cone. Under condition of competition, that's the neoclassical cone. There are no furs. There exists only the aggregate production set that is a convex cone pointed at the origin, bounded, okay, and closed. The boundaries belong to the cone, a sequence of activities that are feasible and converge to a limit activity, implies that limit activity is feasible too. Okay, so the set is closed. And it is the basic analytical tool of neoclassical production theory. Okay. Static, but also dynamics, as you see, and as we will see in this lecture. Is this clear? Now, the way actually it can be used in that formulation in a very simple form is by doing this. And then we'll take a break. Von Neumann introduced two matrices. And here it's when I will need your swift mind, because I always confuse. Remember, I erase it, in the general formulation, there are N commodities and M activities, right? So what we can do is to write two rectangular matrices. One is the input matrix, and the other is the output matrix. By the way, this is what now everybody does in national income accounting. They follow this NOT methodology. Your country has it, United States, every country has the input matrix, the output matrix, the input requirement, the output. In calculating input-output national income accounting with input-output level in a country, and in each country it's actually very detailed, 520 and blah, blah, blah. Okay? I have used it myself. I have never seen the Chinese one, but I'm sure you have somebody working on it. Okay? So how do we do it? Well, we write the matrix, he calls them A and B. So the matrix A is the input matrix, and so what are we going to do? Remember, it's rectangular, right? And so we're gonna write like this: input 1 in activity 1. Input, I have to remember where to put the lambda. Okay. Input 2, then we'll figure out. Input 2 in activity 1. Input 3 in activity 1, all the way to input N in activity 1. Okay? So there is N here, rows, one for each commodity. And then here there is input 1 in activity 2, input 2 in activity 2, and so on until we get to input 1 in activity M. So there are M column here. There is no diagonal, be careful. So the diagonal goes somewhere, but it doesn't go there, because N need not be equal to M. One is bigger than the other, right? We call that the input requirement matrix. If you read it vertically, it tells you for each activity the vector of inputs that are needed. Now we need to normalize each activity, choose one, a numeraire, a normalization. So for each activity we can choose, for example, one input to be normalized at 1 and all the other adjust. And then there is a matrix B. There is the output matrix. And so this has output 1 in industry 1, output 1 in industry 2, and so on. And output 1 in industry M. And so on. You can fill in the rest. Now think what it means if this is a complete description of the technology of an economy. Notice this is a complete description of the technology of the economy. Okay? There's nothing else you need to know but this. Right? These are, each activity is a 2n vector, this and that, and there are m of them. So you can put, these are m rays in the 2n dimensional space, right? You convexify them and you get this gigantic multi-dimensional cone. There is the production set. It fully describes the technology of this economy. Right? Now to describe the production activity of this economy, what is that we have to do? We have to decide at which level we carry out each activity. There are m of them, so we need a vector lambda, which has the form lambda 1, lambda 2, lambda m. That's the level at which we carry out that activity. So, for example, I take activity 3, okay, that has these input requirements. And so x1, 3 means the amount of good 1 in activity 3, multiplied lambda 3. x2, 3, lambda 3. xn3, lambda 3. What is this? Is how much in the actual production plan activity 3 uses of each input. If now you do that for each activity, what do you have? What is that? What am I writing? What's this sum? This is the total amount of good 1 that I need to carry out production at that level. Which means if this is what I'm doing at time t, it must be that this is true. That at time t, I have this amount of the input 1 available. And this amount of the input 2, and this amount of the input n. Right? So this is A times lambda. Where lambda is a column, a row vector, right? Yeah, row, yeah. No. Row, no, it's a column vector. So, well, I wrote it like that. Right. Okay? So this is the first physical requirement of production. Correct? Yes. For an economy. The vector xt, in some sense, is the stock of inputs that you can use during period t. You have not consumed them, you have not destroyed them, you can use that stock of input. It has to be enough to satisfy the input requirement. That's a physical constraint. You cannot carry out production at a level lambda that violates that restriction. Correct? You see immediately that if we repeat this for the output matrix, what do we get? I always get confused, that's why I need your help. So those are the output, right? So if I take a row of B and multiply for a column of lambda, so if I do B times lambda t, what do I get? I get the vector of output I get at t plus 1. We can actually write like this, just for symmetry, because we can think of disposing of it.
Right.
Right?
Yeah.
Well, you see, we just got a growth model and national income accounting all together. I actually have to apologize because now I brought X and Y's. Both Lionel and von Neumann used A's and B's. As entries. I got so used to the X and Y's. Right? It would be more elegant to write little A's for the matrix A, a little B's for the matrix B, but I just got carried away. Okay? So if you want. Right? Because then national income accounting